Hello. How many of you think about your daily commute? Be honest. Few, some of you, maybe all of you. You probably wonder what that has to do with the webinar that we are attending, but I promise I'll show you why. My name is Dino Buljubasic, head of infrastructure department here at Authority Partners, and I want to show you why LLM hosting is actually a first-class business decision. So let's start right away. Actually, first of all, if you have any questions at any point of my presentation, please click on the tab. I think it should be at the bottom right-hand corner. Fire it our way, and we'll make sure we answer or tackle those at the very end. So, daily commute, hey, let's talk about it. How do you get from A to B? Like on a daily basis, when you go to work, when you go back home, how do you do it? There are several ways, obviously. First, there's public transport. Let me just real quick share my presentation. That's the thing that I forgot, but yeah. Okay, so the first thing is the public transport, as I said. You buy a ticket, you grab a seat on a bus, tram, metro, whatever, and you let someone else handle the routes, handle the fuel, handle the schedule, maintenance, and everything else. It's very cheap, it's very easy, but you're stuck with their schedule. If there is a problem on the road, you can't just reroute on your own. You have to wait for it to clear out. So you sort of share every step you make with them. You have to say, you know, it's convenient, it's good, it's quick, but there are challenges that you have to you don't have control over. Apart from that, next one would be rent a car. Like you choose the model of the car, you choose a pickup spot, you choose itinerary, you have more privacy, you pay more, you have to pump the fuel, but you still drive a vehicle that actually belongs to someone else. You have to return it on their own terms. So it's not ideal. The third option would be to actually own a car. That's the most expensive option, obviously. You have to pay quite a lot up front. You handle the fuel, you handle the maintenance, registration, and everything else. But every decision from playlist to modifying the engine to get the peak performance, it's all yours. So when the trip really matters, then you actually have to say that autonomy becomes very priceless. So LLMs follow exactly the same spectrum. Cloud APIs like ChatGPT or Google Gemini or any of the other ones, they're like public transport. You swipe the card, you get an answer. You accept the route, you accept the data sharing as well. If you spin a managed model in a public cloud or you rent a GPU for power processing, that's like your rent a car. You can pick the size, you can tweak settings, you still pay by the hour, and it's still under someone else's rules. Now, if you run it on-prem, that's obviously going to be like owning a car. Now, running on-prem, it's really wide term, and you'll see why. We'll talk about it a bit later, and I'll expand on that. By this analogy, it looks like we only have 3 options, but there are many more, and I'll touch upon that later on. So just like travel, your LLM choice really depends on how much you emphasize control, privacy, and obviously, very important thing, upfront investment. Now, let's talk about what we are going to talk about over the next 45 to 50 minutes. This is just a small agenda. I'll cover things like, what is my motivation to talk about this at all? Then I'll talk about what are those hosting options I just mentioned. It's not just those 3 that we had in the transportation analogy. We'll talk about high-level architecture. Promise it's not going to be too geeky. We'll have a small demo just to show you how you can actually see the difference between hosting something locally and hosting in the cloud. And then we'll wrap it up with some decision-making, with key takeaways and things that we actually want you to take with you from this webinar. Now, I talked about motivation, like what is my motivation to do topic like this? It's actually a very hot topic in the industry right now, and it really, everyone is talking about it more and more. But one thing that made me thinking is this quote from last year. KPMG did a very interesting Gen I survey, and one of the things they found out is that 70% of large company executives actually list external data leakage or data exposure as their #1 worry. Now, at the same time, it's a big number, and I wouldn't be surprised even if it was bigger. But it's understandable. You can see why these people would actually be concerned about this. Like maybe 10 or so years ago, I'm coming from system engineer or sysadmin background. So I remember when big vendors kept telling us, "Oh, we have to move to cloud from on-prem. That's the next big thing. Everyone should do it." And yes, they were right. Moving lots of stuff to cloud made absolute sense and made my life easier. God knows that, you know, if you don't have to update your Exchange server anymore, that's a huge win for you. So the thing is, like right now, people, and mainly due to privacy concerns and security, they start talking about, oh, we should actually consider, because with cloud, with API, with AI, sorry, people actually started doing things in cloud first. And now everyone starts saying, okay, maybe we can run some workload in cloud, yes, but maybe there are things, especially our data, that we should actually move back to on-prem. So we're going other way around. Now, apart from these data privacy and security factors, other motivation includes handling the increasing and sometimes very hard to control costs. That's obviously an important thing to cover. And also, last but not least, choices. You know, it's not just about hosting your AI app in cloud or on-prem. There are many other options in between, and I want to mention and give you sort of a different perspective. So let's dive in. So we first talked about privacy. Like, why do we have these privacy concerns? Like, what is so important? It's simple. Cloud-based AI systems, they send your data to someone else. They send it to some remote service for processing. Now, this approach offers more computing power, sure, but it also introduces privacy considerations since your data travels across different networks and it's actually stored on some external systems. Now, of course, you have to trust their security measures, their policies, and even if they have the strongest measures and strongest security protection and everything, your data is still in someone else's environment, and that can be very, very scary. Not only that, like most of the cloud providers, they by default they use your data and your prompts to train their models. That also gives, I would say, unnecessary exposure to your data and something that you want to avoid for sure. Now, there are industries that have very strict laws about how the data is handled, like healthcare, they have HIPAA regulations, financial institutions, they have different regulations protecting PII data, etc. Now, when you use Cloud API, this can be even more complicating because these vendors might have their own policies and procedures, and also they might store your data in countries that have their own regulations. So you can see why this might be a problem. Now, in contrast, if you host it locally, and we'll talk about different things that actually you have to sort of accept as your loss if you host it locally. Obviously, you can never achieve, well, not, I wouldn't say never, but you can hardly achieve the processing power that cloud gives you. But all your data stays within your walls, no third parties, no transit across unknown networks. It never leaves your control. And that's probably number one thing why you should actually consider this option. Choosing hosting, it's about safeguarding your trust, basically. It's meeting hard data privacy regulations that we just mentioned, and it's ultimately gaining peace of mind. But does it have to be cloud or on-prem? Can we actually have some mix? Can we actually make decisions based on different factors? That's exactly what we're going to cover. Now, we had a transportation analogy at the very beginning. And as I said, we covered only 3 different options with it. Now, cloud, on-prem, and some sort of hybrid. Now, let's expand and use dinner analogy. Let's say you're hosting a dinner party. You have several options. So number 1 is takeaway. You order everything from the restaurant, you have it delivered to your house, and you have the party at home. You have to do the cleanup, but that's it. Easy. Then you can possibly hire a private chef. You know, he'll come to your house, he'll use your kitchen, your tools, but he will bring the ingredients, he will do the job and everything else. The third option would be, and that's becoming very popular, to rent the whole restaurant or to rent a kitchen for yourself. You bring the ingredients, but you use their equipment to actually make meal and everything else. You can buy prepared ingredients. That's another option. You can finish them at home. Then the last option, I would say, and that would be your on-prem, to do everything on your own. You buy ingredients, you cook them, you clean them, you do everything, you host a party. That's where you get probably the biggest reward, because people will actually always compliment on how well you cooked that meat, or how your vegetables taste very delicious. The camping stove thing is like, if you're on some camping adventure with your family, you want to have some sort of a party, but your options are very limited. You have like camping stove, and you can just reheat something, and that's about it. But let's see how that actually translates into LLMs. Now, before I said we have only 3 options, and this table shows us many more. Like, I picked 6. There are probably some other interactive options which you can have. Now, I'm not going to go through the whole table, of course. I'm not going to bother you with all these details. But one thing I want you to remember is that there are different options, like Cloud API, fully managed LLM in Cloud Tenant. You can bring your own model with the managed routine, hybrid or split inference, and then you have obviously on-prem data center. Let's ignore the 7th one for now, and we'll talk about it a bit later. Now, there is one thing that happens when you look at this table and when you go from top to bottom. There is something that's really, like, there's a pattern that you can see. There are actually 3 different patterns. Number one, as you go from 1 towards 6, you're gaining more control with each of those options. You gain control in sense of infrastructure. You gain control in sense of security, compliance, privacy, whatnot. Also, as you go from top towards the bottom, your capex, your capital expenditure, your initial investment rises. So probably options 1 to 3, you have almost 0 capex. You might have some sign-up fees or something like that. You rent more or less, you rent everything. Then number 4, you have some engineering that you have to do, so there is some cost there. And then as you go 5, 6, that's where you actually have to pay big bucks to actually get some infrastructure and build everything that you need to host locally. At the same time, your operational expenditure, your monthly cost, actually lowers as you go from top to bottom, because at the very top you're paying tokens per unit, so you're paying per token your usage. So more you use any sort of model, more you will pay for it, and that can get out of control very easily. So you have to be very careful here. Of course, there is expenditure with power, cooling, and expertise for local options as well, but that per token fee almost disappears once your utilization of your local infrastructure is actually high enough. So why does this matter? Well, it can give you a really clear picture of where your next AI project should live. I would say that most of the startups and even some POCs, they live in 1 and 2. It's not just that. Like, many companies start at that is easiest. You just spin up, you create an account at OpenAI, and you get an API key, and you start building your application. It's very easy. You move towards 4 or 5 once your workload's mature enough. And of course, once you have critical workloads, or as we just mentioned, when you have privacy and security concerns, then you start thinking about option 6, where you trade cash for long-term control, basically. So there's no universal right choice. It's just whatever aligns with your priorities. Now, the 7th option that I just mentioned, we'll talk about. It's like edge or local devices. Imagine remote area, like an oil rig or something like that, where you want people that work there, you want them to have maximum usage of your AI application, but their internet connection is awful. They don't have any infrastructure or anything. That's where we have these small devices like NVIDIA Jetson Nano, which can actually run these small models and give your users a very good experience for a fraction of a cost. So why all this matters? Like, what's the key message here? So let's try to bring this home. Picture 2 product teams. It's the same company. They have same goal. They have same launch day. Let's say that way. We on the left hand side we have team A, and they actually decide to use public LLM. They have their kickoff on Monday. By Friday, they already have functional prototype. They can do their demo. A couple of weeks later, they actually have polished solution. They can go live. They can go to production. So what is their superpower? It's speed, right? They made sure to capture the market opportunity very fast. Now we have team B. They decide to build a private cluster. Their journey is longer. They have to think about procurement. They have to build the infrastructure foundation. They have to do all these MLOps wrangling, training cycles, retraining, optimization, whatever. But a couple of months later, they actually have their launch day. They actually go to production. Everything is fine. Their inference costs, they're very predictable, and their security officer sleeps very soundly, because he knows that data never leaves their walls, and the security is actually tailored perfectly. So who won here? That's the question, right? I think they both did. They just won on different scoreboards. So team A dominated, as we said, they dominated speed to market scoreboard, while team B dominated, let's say, long-term efficiency and security scoreboard. So their victories, they both won, but their victories are fundamentally different. So this is, I would say, a core of approach meta principle. It's hosting choice should not be a backend technicality. It really is a pivotal business strategy. It's just like if you choose a rental car for quick trip, or if you actually buy a car for daily control, just linking back to the actual original analogy. Your LLM hosting choice will actually critically shape your innovation pace. It will shape your cost structure. It will shape your ability to actually earn and keep your customers or clients' trust. So, as I always say, just choose on your definition of winning. That's, I think, the key message here. Now, I'll cover some architecture blueprint and how all these pieces fit together. This is more or less unified. It's not something that you can find online easily. This is something that we created just to have actually understanding of what happens under the hood. But it's unified regardless of whether your LLM is in cloud, or it's hosted on premises, or it's some hybrid solution. The only difference is that on-prem, we can easily see all of these. We can see all of these layers very easily. We know exactly what happens at each of these layers. While in the cloud, you probably see only experience layer, and to some control, to some extent, you see access and control layers, and that's about it. So let me just go through this real quick. I promise it's not going to be too geeky. At the very top, we have experience layer. So that's basically a web chat, that's Teams plugin, maybe even some voice EVR. Everything below this experience layer exists to make this experience layer fast, accurate, and trustworthy. Below that is access and control layer. It's very simple. Like, it's some sort of like a smart reception desk, let's call it that way. So it checks your badge, it watches the request volume, so nobody actually hogs the system. It keeps a clean audit trail and everything else. So this layer sort of helps us to know who used the model and when they use the model. After that, we have model serving layer. That's basically the brain of the whole thing. Think of it like a smart dispatcher for taxis. It knows which cars or GPUs are free at the time. He sends customers or prompts to them quickly. He just keeps everything running smoothly. That's why we call it the brain of the whole thing. Compute layer is the muscles. So that's where you have racks of GPUs, which can be scaled to per demand. You can scale it up, scale it down, whatever you want. Obviously, that's the part that lives either in your data center, if you want to host it privately or on premises, or it can live somewhere else. You can rent GPUs per hour, or you can actually just rely on cloud to do everything for you. Finally, at the bottom, If we said that model serving layer is the brain, then data layer would probably be the heart of the whole thing. It holds company documents, it holds databases, logs, and everything else that model might need to answer questions accurately. Just to give you an example, like authority partners, we have this chatbot, which is integrated into Microsoft Teams. We call it AP Assistant, and it basically gives you answers to questions like, it goes through our policies and procedures, and it can answer questions that you might have regarding whatever is within those policies and procedures. So you might ask it, how many days of vacation I have, and it can actually go through the policy and say, based on your position, you have that many days, or whatever, or anything else you need to know. You can just ask the assistant, and it will actually. So that's the data layer. That's your database. That's your PDF files and everything else that actually where you keep your data. Now on the side, we have these two layers that are actually also very important, but not really within the actual layer. They actually oversee all the other layers. DevOps or MLOps pipeline. Think of it like assembly line or in a mechanic shop. You have automated builds, you have automated tests, you ship code, you have model updates and everything else. That's all done within this layer. And then you have observability and governance. Basically, it's like a control tower. It watches every request, measures performance, keeps track of cost, security, compliance, and everything else. So as you can see, even on-prem, the LLM platform, on-prem or in cloud, LLM platform is basically just another tiered enterprise application. What does that mean? Well, it means that all the skills, all the tools, and all the governance patterns that you already use to build other applications, they still apply for this. It's absolutely not different. I'll go ahead and get rid of this laser. So I want to talk about two different principles that we use at authority partners to help our clients to actually make their decisions. First, there's this table with simple 6 drivers that can be your compass. Of course, there are others that people can use or companies can use, but these, I would say, these are the 6 main ones. And here's the reality. Every company sees these differently, and they will all prioritize them differently. So if you're racing to launch, speed would be your main driver. So you would say, okay, speed is my main driver. In cloud, I can get this application up and running really quick. If I want to do it on-prem, it's going to really take me a couple of months. So no, I'm going to do cloud API. So my driver is speed to market. Or your driver might be budgets. Budgets are tight. So you have to think about cost efficiency. So you go through this table and you say, okay, cloud API, it's pay as you go. Yeah, that sounds good. I don't have really budget to go big and invest in some huge hardware. I'll just go with cloud API, or I'll just rent some GPUs to make adjustments. So the hosting choice is not about losing anything. It's really about aligning with what matters most to you right now. The key is just to column your strengths to your KPIs. So as I said, I think already before, it's not cloud versus on-prem. It's really to match your infrastructure to your current priorities. And the second thing I want to mention here is decision workflow. Basically, what you see here is very similar to the questionnaire that we run in our client workshops during our AI Academy and AI assessment. Of course, these depend largely on client needs and wishes, but essentially, they come down to few important questions that you have to ask before you actually make a decision where to host that next AI application. So the first and probably the most important question is about data sensitivity. And we talk about this already. If your data is GDPR regulated, or if it's HIPAA regulated, or anything else, your choices are becoming somewhat limited. Privacy and regulations, they trump everything else. The only other question that comes to mind after you decide, whether data is sensitive or not, is how important is latency? If it is, then probably on-premises infrastructure would make more sense to you. It doesn't mean that it's the only choice, but it will make most sense. If your data is not sensitive and it's not regulated, then the whole bunch of different questions open up. and they become important, they become influential. Like, how important is the customization? Do we have skills and budget to do this? How do we care about capex or opex? Which one is more important? Which one is easier to handle? How quickly do we want to push this out? So all of these can lead us to one of these three options, or as I showed in a couple of slides ago, 6 or 7 different options. Important thing is to understand each of them and to treat them with enough importance. That's the only way we can actually make the right decision. So let's see, like a real case, real world scenarios, like 3 different scenarios. Use case number 1, we have a shop site chatbot. So the backstory is, let's say we have Black Friday, thousands of shoppers, they ask, is this in stock? Do you have this color? Blah, blah, blah. So users will usually leave that site if the answers lag more than, I don't know, 5-10 seconds, a minute, whatever it is. So that responsiveness and that fast response is the most important thing for you. So that only big public APIs or these rent GPU companies can actually provide you enough muscle to spin up thousands of GPUs on demand just for the Black Friday days. And then later on, you just spin it down and you keep using your AI chatbot on a regular basis. So your probable decision here would be to go with public LLM. Now, if we have a franchise inventory agent, let's say we have a store that has 10,000 outlets. They do weekly counts via emails and faxes. Now, you have AI agent that works only from, let's say, Sunday to Wednesday. Now, buying hardware to actually sit idle for most of the week would be absolutely crazy. So we actually build some stuff at home. We hold our data at home, but we simply rent a cloud GPU for 48 hours. The agent does its work, completes, we scale it down. We don't need it anymore for the rest of the week, and we are happy. Our documents are actually processed, sent. So rented infra plus private LLM would be the best choice for this use case. And the third one would be hospital treatment advisor. Let's say you're a hospital, you want some sort of AI assistant to suggest you better care plans. Now, the data here, they're medical histories. So that means they're highly protected. Hospital is most probably HIPAA regulated. Speed target, it's not that important how quickly you get the answer. So let's say 5 minutes or so. So we're not chasing milliseconds. So the safest way, would be to keep the model where the records already live, really. So in the hospital data center or regulated some other cloud region or something like that. So you have full control, you have full audit trails, and you sleep well at night. So 3 different stories, and to refer back to the previous slide, you have 3 different winners. Now, I want to show you a very simplified cost comparison between different hosting options. Let me give you a background first. Let's say we have a mid-sized retail chain that has several dozen physical stores. They have e-commerce portal and they have online customer support. Now, they want to use AI to optimize customer experience, to do logistics, and to do engagement. Now, what we have here in this table is simple cost comparison for their, let's say, AI customer service chatbot. It handles inquiries, order status, complaints, and general support. It works 24/7, and let's say their estimated user count is between 500 and, let's say, 2,000. So obviously during the holidays, and as I mentioned earlier, Black Friday and these things, it's going to be higher. The easiest option from the technical perspective would be to go with Cloud API. You just choose your vendor. Your CapEx or your initial investment, obviously it's 0, or you might have to pay for some joining fees, obviously. There's no hardware purchase. So typically, LLM endpoints in cloud for enterprise customer support, they cost between it's let's say it's between 360 and the minimum that you can pay. Now, depending on usage, obviously, your operating cost can vary between 0.002 to 0.06 per 1,000 tokens. And that's the pricing range approximately for most of the vendors. Now, your typical chat support session is, let's say, 5,000 tokens per user. And your monthly OpEx gets anywhere between $360 and $10,000. You know, it really depends on usage, depends on API model, depends on provider. Plus, you have integration, you have monitoring, you have premium support and whatnot. If you want to rent a GPU, typical cost can vary between 50 cents to $3 an hour. It's for moderate GPUs such as A100 or T4. Again, your initial capex is zero, apart from the joining fee, and that varies from provider to provider, obviously. And you know, typically you get to the price range between $400 and $2,000, plus all the other things that I mentioned, just like for cloud API integration, monitoring, support, and everything else. And then we get to local LLM. We have three different options. These options are based on, you know, how much budget do you have to actually cater for this. So you have low option where you just go with some RTX GPU, where you know it can cost you up to $3,000 of your initial investment, and then you have about $100 or something like that of your monthly expense for maintenance, for power, and everything else. If you want this chatbot to be really good, then you're going to medium, where you actually have one of these RTXs and you build a cluster of them. Obviously, depending on how many you're going to use, it's going to cost you 2, 3, 4 times more than the initial one. And then we have high-end options where we're talking about, you know, A100 or H100 GPUs, where investment is quite high, but you get your maximum security, you get your in-house control, you get the option to run any other application, not just that chatbot that you built for yourself. But please, this is just for illustrations, just to tell you how much the capex and opex vary between these three options. Do not think that you're going to pay that much or this much for any of your projects. It's really something that you have to go through, and as I explained earlier, there are a lot of things that we do at Authority Partners to actually help our clients to understand where their next AI project should lead. Now, I want you to do a little poll for me, please. After this, we're going to do demo. So by the time I prepare a demo, hopefully some of you guys will actually vote on this one and give me some, actually, I want to know, like, where do you think your main LLM project will live, like 18 months from now? So please just scan the QR code on the screen, or you just go to slido.com and just type in this number you see on the screen, and you can put in your responses there. And it will just give me a few seconds to actually power up my demo and to show you something. Just give me 1 second. So we already have one response. That's good. Okay. And this is very important. Like, it really doesn't matter if you are pro cloud or if you are pro on-prem. You guys choosing not sure, but you got me thinking is actually what I want from this. We want to help you to actually make that decision. We want to talk to you. We want to work with you to give you understanding of what your options are, and to make sure that your next AI project really does what you want it to do in a secure and a proper manner. So this is good, as I thought. We'll have the not sure option that's actually winning. So no one wants to rent a GPU. It's actually a very, very common that people are not huge fans of this, but I think it's quite a good thing. You know, there are a lot of different vendors that do this. Runpod is the one that I used in the past, and it really has some amazing options. cost can skyrocket very easily, even worse than if you use one of the cloud APIs. But yeah, it's a good option. I'm really recommending for any of you to try it, because it can give you a different perspective on how you can actually build different applications. So thank you very much for taking part in the poll. I will move on now to demo, and let me just stop sharing this presentation so I can actually share my screen for the demo. Now, actually, let me just share it first, and then I'll give you the explanation what the demo is all about. So I want to share this. Hopefully you guys can see it. Yes, you can. So what is the demo? I will try to show you, I created a simple application that will actually show you, normally when you use Cloud API, you don't really think about how much it costs. At least you don't think about it at the very beginning when you start using it. Your main driver is basically to make sure that you actually get the application up and running. I want to show you how you can create a simple Python script that will actually give you a perspective of how your requests or how your prompts are being handled. So this is just a different laptop that I'm just connecting to. It's not really too powerful. It's more powerful than the one that I'm using for the presentation. And I'll show you real quick. It has one of those, where can I see that? Probably under help and system information. It has 32 gig of RAM, and the important thing is it uses NVIDIA RTX 4090. It is a laptop edition GPU, but still it performs much better than these integrated GPUs. So what we have here, we have locally installed Ollama. As you can see it here, it's running. And just to make sure that it's actually running, just 1 second. Okay, so let me just refresh this. Yes, Ollama is running, so that's good. I will put this down. Now what we want to do is, I'm sorry, I have to just, I don't see my screen properly, so I will start the Windows PowerShell. Actually, while this spins up, I'll show you the actual, this is the actual script. So it's a simple Python script that will actually connect to Azure OpenAI API key. It will use, from memory, I think it's going to use GPT 4.0 mini. And we have, as I said, local Ollama server that actually will serve this tiny llama 1.1 billion parameters model. And it will actually compare the speed, and it will compare the cost for both of these. Well, actually, it compares the speed, but it just gives you the cost because local one does not have any cost. So the first thing I need to do is, okay, so I need to grab this path. I'll just paste this here. So next one, I'll start the Python environment. Should be -m .benv. Okay. And now I'll actually activate the script. So it should be this path, scripts, I think. I have one I scripts, and then activate .ps1. Hopefully that's fine. Yep. And then we'll just run the actual script, which is called bench py. So what we'll do, it will actually grab 3 different prompts six different prompts, 3 short ones and 3 long ones, and it will pass them on to local Olama server and to Cloud API. And here we can see that Cloud API performs much better, simply because this laptop is not powerful enough. If we had some strong GPU unit, it will probably perform much better than any cloud provider can. But as you can see, some of these things, and I'll show you real quick, I think I have prompts in here. So short prompts are define zero trust in one sentence, translate to German one small sentence, list 3 pros of hybrid cloud, and long ones are a little bit more complex. And it basically goes through this, and it gives you a nice indication of how quickly it actually got the response from both of these. So obviously the local one is slower because we have very limited infrastructure. But what I wanted to show you is if we go back to this here, it actually, the script generates this results HTML. So if I open results HTML, I'll see the same things, you know, local model latency, GPO 4.0 latency. But what's important here, we have GPT 4.0 cost, something that we don't have for latency. Of course, this is very low. Don't get me wrong. You know, these prompts are very small, and we did not really get charged much. But imagine if you have 500,000 users doing different prompts on a daily basis. These here would not be 0 point something, they would be much, much higher. So I just wanted to show you how it's that using Cloud API can lead to huge cost very easily if you're not careful enough, if you don't pay attention. And having something like this, I know you can always track that in if you're using it through Azure or through OpenAI or Google Gemini, whatever you use, you can track your expense there. But I think having script like this is also important to give you understanding of what's happening in behind as well. So that's all I wanted to show you for now. Now let's go back to our presentation real quick and wrap it up slowly. So we are done with demo, and if you remember nothing else from today, there are 4, let's call them truths, that will keep your AI roadmap off the front of the TechCrunch for all the wrong reasons. The first takeaway, prototyping cloud. Basically, cloud APIs are your new whiteboard. You spin up the model, you test it. If it's not good, you kill it, you do it again, or you actually double down. When the finance officer starts whining about the token invoices, or when security officers start asking about residency, about privacy, about security, that's when you have to step up your maturity ladder. Number 2 is the iron triangle, like latency, privacy, and elasticity. We basically treat them the same way that developers will actually treat scope, time, and cost. You can really get all 3 green at once, but the important thing is that you call out the red one before it's too late. Takeaway number 3 would be private is not just on-prem. I think you got that by now. A lot of people still picture private as, you know, server room with flickering fluorescent lights and everything else. You know, it's important to show them like GPU, cloud tenancy with customer managed VNet and everything else, so they can still have private LLM, but someone else takes care of the infrastructure. And the last one, not least, industrialize the choice. We showed you the flowchart. We showed you the table that can be very useful with drivers. A product owner or any client can really answer 5 to 10 simple multiple choice questions through our AI Academy or AI assessment, sorry, and they can get deployment recommendations. They can get cost band before they actually make their first sprint. it's important to have governance that accelerates and not slows down innovation. So before we wrap up, let me take a moment to zoom out. We explored the decision-making process behind hosting large language models, balancing privacy, performance, scalability, and everything. These are not just technical questions, these are strategic ones, and they can define how organization actually innovates with AI. At Authority Partners, we see innovation as an ongoing journey, basically. Our work with mid-market and enterprise companies, it always focuses on helping them identify where AI can actually create measurable value, from initial discovery and strategy to production-ready systems. So whether it's rethinking your architecture or just enabling your teams to experiment safely, we will help you to move from idea to implementation with the confidence. Today's topics, I think we sparked the ideas about where LLMs might fit into your organization. Our agentic AI assessment is something that I mentioned already. That's a great next step. It's literally structured way that enables you to evaluate your current AI landscape. It enables you to identify opportunities for automation. It gives you intelligent agent design. It simply builds a roadmap that can align with your business goal. So it's not about just pushing technology. It's about finding the right fit for your content. Questions? Let's see if you guys were actually paying attention or not. Also, if you like to continue conversation, feel free to reach out through this chat. Feel free to reach out on our email, on our website. There are a lot of ways to contact us. Please feel free to reach out to me via LinkedIn or any other social network, or simply just shoot us an email. So real quick, let me just check if we have any questions. Looks like we do have some. The first question. Okay, so I have two questions that we will try to answer. The first one is, you mentioned edge local device on one of your slides. Can you please elaborate? What do you mean by that? What is the use case scenario? So that's actually a very good question. It's actually one that it's not the first time that people ask me. I try to explain a little bit, but let me just be a bit more detailed. Let's say you already have a strong on-premises data center. When I say edge or local LLM device, what I mean is small scale deployment that can actually bring your inference cost, that can bring your inference much closer to where your data is actually generated and where it's found. It doesn't have to be in the cloud. It doesn't have to be in some central data center. So use case would be, like I mentioned before, it might be some offline or remote operation. It might be some privacy critical environment, like we have healthcare, you have retail, you have finance branches where you just cannot have that data to leave those premises. So that's when you actually try to use one of these edge or local devices. It's literally like a local mini server that runs some quantized model. You have almost real-time inference. And, I mentioned NVIDIA Jetson, there's AMD Ryzen AI, there's Apple, I think it's called Neutral Engine or something like that. So there are many options out there. So investigate. It's really cool thing for these specific needs. And the other question is, we already have solid infrastructure in our data center. If we were to go down the path of hosting our own LLM, how much would that help, or how much we can save if we already have something? And that was asked by Dennis. It's a good question. I mean, if you have your data center, it can help, absolutely. Your CPU from your servers or your RAM, it can help hosting containers. It can help to handle the API traffic, caching, branching, monitoring, and everything else. But the thing is, the main investment still remains GPU. GPU architecture is specific. It's different from CPU architecture. It gets a bit geeky at this point, but in general, the way GPU and CPU process operation, it's completely different, and it differently affects how they handle LLM. CPUs can handle smaller LLMs, few tokens per second, 1.1 billion token, or tiny llama that you saw on my laptop. But if you want anything even remotely serious, 20 billion models or even 7 billion models, I think you have to get something. You have to get a GPU that's actually powerful enough to help you run that. And we just have another question. It just popped up right now. You emphasize the need for governance that accelerates rather than slows innovation. How do you imagine aligning this with federated LLM architecture and real-time credentialing frameworks where accountability is built directly into the inference pipelines? This is from Edin. The question comes from Edin. Thank you. It's not easy for me to answer this in this timeline, to be honest. It's something that needs a bit of thinking. Federated LLM architecture and real-time credentialing frameworks, it's something that's becoming really popular. I know it's built in, but I think it's important to find the real difference between how you want to make sure that any type of governance does not slow you down in any way. I think that's number one thing. And let's connect after this webinar, and I would love to discuss with you this, because it's a really interesting question. But as I said, it requires a bit more thinking, and it requires a bit more time to actually answer it. The last question I have from, I think is it John? Yes. Can you help me assess the best hosting strategy for my AI project? Absolutely. As I said, we run AI assessment service at Authority Partners. It's something we are really proud of. We can really just sit down with you, with your executives, ask you a few questions, get you to fill out the survey, and that will give us fantastic outlook on where you think we can help you the most. And then we can work together to actually find the best way to host your next AI project, and to even find out what your next AI project might be. Thank you very much, everyone. Okay, I'm just looking at if we have anything else. Yes, at this point, I just want to thank you for joining me, and I'm looking forward to seeing where your next LLM hosting journey takes you. Cheers and take care. Goodbye.